Next up, all the way from the Earth and Environmental Sciences, please welcome Anne Villacastin.
Hiking uphill to the Lawrence Berkeley Lab, in comparison to walking on the flat beach, is undeniably different. What the map service on your phone using digital elevation models might tell you it's the same distance. This ambivalence about topography does not only affect navigating your life, but also the sciences we do at the lab. Here, we use grid or pixel-based models at all scales. As an earth scientist, I use them, for example, to quantify the areas affected by landslides or wildfires. But I found current models underestimate the real surface area by up to 30%. This is an unacceptable error margin, whether on the nanoscale or for Yosemite Valley. So I investigated and I found 3 problems. The first problem with topography is that we simply ignore it, and we only give the 2D horizontal area. If we would consider the 3D information at hand, we would see that the horizontal grid forms a triangle with the elevation. And if you remember trigonometry, the sloped edge is always the longest. This brings me to the second problem with topography. We measure it remotely, from a bird's eye view. Sampling in this view horizontally spaced points, you will only place a few points on steep slopes like the face of Half Dome, and no points where there's an overhang. Well, looking at this, you might say, let's just go to higher resolution. This is actually the third problem with topography. Regardless of the resolution or the scale, the underestimation and the unequal sampling of sloped surfaces persist. Turns out, topography is not the problem. It is how we model the data we got. But on the bright side, explaining this problem to you, I already shared the solution. As it all depends on geometric relations, we can use trigonometry to resolve the error. It is as good as a mathematical surface integration, but faster and with less math. And we only need a few additional lines of code. So now I can accurately quantify Earth surface processes. My colleagues can check the real surface area of new carbon capturing materials. And you can brag about the actual distance you made, assuming you all hiked to the lab today.